Hi, welcome to the Python Programming for Machine Learning video series. If you've ever wanted to build your own machine learning model, then this is the right place to start. In the next 10 to 15 videos, you'll learn all about how to code using the 4 Python libraries necessary to know about in order to effectively utilize arrays and matrices, analyze data, and plot data, which are arguably the most important aspects of ML models, for which data is the core. So why exactly are we using Python? Well, Python is extremely powerful, easy to use, versatile, and has great readability, meaning the syntax is not confusing or misleading, which makes it a great first programming language. And as a benefit to AI, it has several programming libraries linked to it that are useful for machine learning and data science. In this series, we'll be looking at the 4 most common and important Python libraries for ML: Numpy, Pandas, Matplotlib, and Seaborn. Now, as a quick side note, the series won't go into the very basics of the Python programming language itself, mostly basics of Python for these 4 libraries. That said, you won't have to be an expert on Python to understand the content in these videos, but a little background knowledge on programming as a whole might be helpful. So first, we'll be looking at the Numpy Python library. Some pronounce it Numpy, while others pronounce it Numpy, but I'll probably use both versions interchangeably. So Numpy is a Python library that provides a multi-dimensional array object. Multi-dimensional meaning you can have arrays, and things like that. Numpy provides several built-in operations for arrays, such as sorting, selecting, and mathematical operations, etc. Now in theory, Numpy arrays look quite similar to Python lists, but Numpy arrays are actually much more effective in terms of size, performance, and functionality. They take up less space in the memory of a machine, they have faster computational abilities than Python lists, and they have more optimized and advanced functions. Next, let's take a look at Pandas. Pandas is a powerful library that allows you to analyze data with Python. It takes data, for example in a CSV file, and creates a data frame, basically a Python object with rows and columns that looks like a table or an Excel spreadsheet. This is much more effective than data analysis using just Python lists, dictionaries, etc. Now let's talk about Matplotlib. Matplotlib is a Python library for plotting data and creating data visualizations, such as line graphs, bar graphs, scatter plots, histograms, 3D plots, pie charts, etc. Plots help us understand trends, patterns, and correlations between the variables we're working with. And Seaborn, which is the last library we'll be exploring, is basically an extension of Matplotlib, as it also helps with data visualization, but has some more advanced features, such as more plot options, better personalization, meaning fonts, color, and advanced output. Now, for all 4 of these libraries, you'll have to install some packages onto your machine. The installation instructions for each of these packages is linked in the description below. You'll also need to download a Python IDE or a workspace on which you can type and run your code. I'll be using Jupyter Notebook that's part of the Anaconda distribution for these videos, and I highly recommend you get Anaconda and use Jupyter because it's extremely easy to use and it's highly efficient. If you already have a workspace, then you can skip this step, but if you don't, then you can follow the instructions on the website linked in my description box below. So in this video, we'll be exploring the basics of NumPy, and we'll be taking a look at NumPy arrays. Our lesson structure is outlined here. We'll first go into NumPy arrays using Python lists and matrices, and then we'll be going into NumPy arrays using built-in NumPy functions, NumPy array methods and attributes, and finally we'll be looking at how to create random NumPy arrays. And with that, let's jump right in. Okay, so the first thing that we have to do is import NumPy, and we're going to import it as a variable, and we're going to call it NP. Okay, so the next thing we're going to do is turn a Python list into a NumPy array. And so we're going to do this by creating a variable called ARR and writing np.array, which is basically creating something into a NumPy array, and we're going to input a Python list 10, 20, 30. And now we can print this out and see how it looks. And it looks like a list, but the difference is this is actually a NumPy array, so we can perform operations on this array that we couldn't do if it was just a Python list. And we'll explore these operations in a later video. So the next thing we're going to do is create a variable called mat, which is short for matrix, and we're basically going to turn a list of Python lists into a multi-dimensional NumPy array. So we can type in the variable name in the cell, and it outputs this nice matrix-looking array. Now notice how we didn't say print mat, and so that's why it has the array in front of it. But if we say print mat, then it'll remove the array word, and it'll just output a matrix, just like that. So now we're going to explore some basic built-in methods that are specific to Numpy. So the first is np.zeros, and this one is pretty self-explanatory. It outputs an array with zeros, and the number in the parameter indicates how many elements you have in your list. The next one we're going to look at is np.zeros, but with 2 parameters. And this one is basically going to output a multi-dimensional array, all with zeros again. And it will kind of have the same layout as our mat variable above, because they're both multi-dimensional arrays. Now the next one is np.ones, and this one is also pretty self-explanatory. As you can see, it outputs an array with ones. And we can again do that multi-dimensional form of it. So the next built-in function we're going to look at is np.I, which basically outputs an identity matrix that has the number of rows and number of columns as what you specify in the parameter. And you can look up what an identity matrix is on your own. I won't go into that in this video, but basically just know that it kind of acts as like an inverse matrix. So I'll write it right here, and you can look this up if you're not familiar with it. So the next function that we're going to look at is np.arrange, which is a really handy function because you basically enter a number and it creates an array of that length for you. It starts from 0 and goes all the way up to 1 before the number that you type in. And notice how that has 10 elements, which is what you've specified in the parameter. So you can go ahead and check that out by typing in AR equals np.arrange and then 10 in the bracket, or in the parentheses, and seeing what it outputs. And we can also try changing this to 8 and seeing what it outputs, and this will just be an array from 0 to 7, which has 8 elements. So the next thing we're going to look at is the same function, but with 2 parameters. And this one is basically going to start at the value you specify and end at the value you specify. So the first number in your parameter is going to be the initial starting number, and the last number is going to be what you stop with in your array. And what this is going to do is it's basically just going to create an array of whatever length it takes to get from the starting to the end. And it's integer based, so it just goes number to number until it reaches the end. So for the np.arrange function, we can also supply 3 parameters. So one way to see kind of how many parameters and what types we need, we can do Shift-Tab, and that'll bring up this docstring where we can observe what parameters it can take. So we see start, stop, and step. So we've explored start and stop, and now we're going to look at what step means. So let's start out with the same 5 and 20, but then we'll add a 4 at the end this time, and we'll see what happens. So we see that this array also starts with a 5, so that stays the same. But we see that it kind of increments by 4 every time. So 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17. So the 4 at the end kind of indicates what it was saying before, the step, which is kind of how much it adds every time. And it only ends at 17 because once you add 4 to 17, it exceeds 20, which we don't want. Okay, so now we're going to look at ar.reshape. So this is another built-in function of the Numpy package. So what this does is it kind of reshapes an array. So previously we had just an array with 1 row and 10 columns, which was what AR was initially. But now that we've reshaped it to have 2 rows and 5 columns, we're still going to have all our elements, but they're just kind of rearranged. So one way to see if a reshape will work is if both the values multiply to the original parameter. So 2 times 5 is 10, 5 times 2 is 10, so both of those work. And we can actually see the shape of this, and it'll just output 2, 5, because that is the shape of our reshaped array. 2 rows and 5 columns. And we can also try outputting 110, which is going to output the same thing as we had before when we had np.arrange and a 10 in there. Basically 1 row and 10 columns. And we can also try rearranging this version, and we can say 10, 1 instead, which will be 10 rows and 1 column. So you can kind of just see how we're reshaping the same array, basically that has the same elements, because 10 times 1 is 10, 1 times 10 is 10, 2 times 5 is 10, and 5 times 2 is 10. So here are just a few more functions that are pretty handy. So this one is self-explanatory. It finds the max in your array. So in this case, that is 9. And then we're also going to do the same thing to find the index of the max. And in this case, it's also going to be 9 because our indices actually line up with exactly what numbers in paired with each index. But basically, argmax finds the index of your maximum value. Next, we're going to look at the min function, which finds the minimum value, and we can also do argmin on this one as well, which will find the index of the minimum value. Now we're going to look at random. So np.random is what we're going to start with for creating random arrays from now on. So we're going to start with np.random, and then we're going to say randint. And what this does is it basically finds a random integer between the two values that you specify in your parameter. So in this case, it's 19. So we can also supply 3 parameters. So I basically copied and pasted the previous line and just added a 3 to the end, which basically outputs an array with 3 random integers from 5 to 20. Now we're going to look at just rand. And what this does is it outputs an array with length, whatever you specify in your parameter, of values between 0 and 1. And so they're all going to be decimals between 0 and 1. Similar to this, we have np.random.rand with 2 parameters, which is the same concept, but a multi-dimensional array. So now we have the same thing, but we're going to add in a little letter here. It's an n. So rand n is, it goes from -1 to 1 instead of 0 to 1. And it still outputs an array with length, whatever you specify in the parameter. And we can also make this into a multi-dimensional array. So they're all going to be values between -1 and 1. They're all going to be decimals. In this video, we're going to be exploring NumPy indexing. We'll learn about indexing, selection, slicing, broadcasting, and we'll end with relating Booleans and arrays. Let's jump right in. Okay, so to start this off, we're gonna import numpy as np again, just like in the last video. Next, we're gonna start by creating a basic array that will perform some indexing and selection on. So we're gonna do this by saying array equals np.arrange, and then a 10 in the parameter, which is going to indicate an array that has 10 elements, starting from 0 up to 9. Next, we're going to grab the element in the 0th index, so we just do that by doing square brackets and a 0 inside. Now we're going to look at some slicing. So 0:4 will just take the first 4 elements of our array, which is 0, 1, 2, and 3. So now we're going to perform indexing and selection for a matrix, which is basically a 2D array. So we're going to create another variable, call it array2, and equal this to np.array, and we're going to insert just a multiple Python lists. And if you saw my last video, you kind of see how this is turned to a NumPy array, a multi-dimensional array in this format. So this is going to be our list of Python lists. We'll do one more. So this is going to be a multi-dimensional array with 3 rows and 4 columns, as you can see right here. So to get the row, we can say array2 square bracket 0, and that gets the first row. And then if we want to get a specific element, we can say 0 and then another square bracket with 0. And this gets 2, because it's the first row and the first column. Okay, so now we can look at slicing for 2D array. So for this, we can basically have a comma that separates out what we want to slice. So here we see 1 colon, which basically takes the row in the 1th index, so 0, 1, 2, so we're going to take 3, 4, 5, 6, and then column starting at the 1th index, so from 4, 5, 6 onwards. Okay, so now we're going to look at backwards. Same concept, but basically instead of going from 1 forward, we're just doing everything until 2. So you can kind of analyze this further, but basically we're going to not do 2, and so just 0 and 1, which is kind of like the premise of slicing. We want to take everything that's before what we end with. Now we're going to talk about broadcasting. So broadcasting, basically we're going to say how or what elements we want to be broadcasted. So in this case, I did just a colon, which says everything needs to be broadcasted. So and I equal that to 10. So now everything in array is now 10. So now I just recreated our original array that hasn't been broadcasted. And we're going to look at how to kind of select a couple and change just those. And we're going to see how when we change this, it becomes permanently changed. So we're going to have to make a copy of the original array before we change it. But I'll get into that a little bit later. So here I've just selected a portion, the last 5 elements. And I've equaled that to 1. So now, as we can see, the original array is changed. The last 5 elements have all become 1. And this is permanent, so changing a slice of the array changes the whole array permanently. So one way to fix that is to copy the array before we change it. And so when we take a copy before we change it, we still have the original array and our changed array. So now we're going to talk a little bit about how to relate Booleans and arrays. So this is how our array now looks since it changed it permanently. So now if you say ARR is greater than 1, it's going to give us trues for wherever it is greater than 1 and false for where it's not. So as we can see, the 2, 3, and 4 are all true because they're all greater than 1. Now, if we put this back in as kind of like in the square brackets, it'll just return the ones that were true. So this is a way that we can kind of filter it down. So in this video, we looked at how to perform slicing on arrays, single dimensional and 2-dimensional. We also looked at some how to kind of get elements in 2-dimensional arrays and how the indexing and selection works on those. Then we also looked at broadcasting. So broadcasting basically where we assign select elements as another variable and it changes it to that. Then we saw how taking a portion of that and changing that portion will permanently change the original array as well. So we need to take a copy. Then finally, we saw the relationship between Booleans and arrays. In this video, we're going to be exploring Numpy operations. Our lesson structure involves learning about addition, subtraction, multiplication, and division with Numpy, advanced mathematical operations, as well as some other functions like ceil, floor, trunc, and absolute. Let's jump right in. So in this, we're going to import Numpy as NP as always. And we're going to start out with creating an array that by using the np.arrange function with a 10 in the parameter. So this will create an array that is length 10, starting from 0 all the way up till 9. So we're just going to see some basic operations here, some math operations. So ARR plus ARR, this is basically just going to add every element in the ARR array. So it's just going to double each element basically. So this is known as element-wise addition. So we're going to perform some element-wise subtraction now. And that because we're subtracting each element from itself, we're just going to get a bunch of zeros. So now we're going to try doing some multiplication. This is just going to perform element-wise multiplication. So it's just going to multiply each number by itself in this case. Now we're going to do division. In this case, it kind of gives us a little warning. It's not crashing, but it's just saying that in the first one, we're performing a zero division. And so it's outputting NaN for that first one because 0 divided by 0 is undefined. Okay, so now we're going to do ARR times 2, which is basically going to multiply every element times 2. And now we are going to do exponents. So ARR and then the double multiplication sign 4 is going to take everything to the 4th power. So as we can see, we have like 81, and so 3 to the power 4 is 81, and that aligns with the 3 in our original ARR array. So we can kind of see how that works. Now we're going to perform some general mathematical operations that are a little more advanced. So here is np.log. If you aren't familiar with logarithms, then you can search that up in your own time. But basically, these are just some operations that are existing in the NumPy library that we can use on a NumPy array. So here is square root, basically take the square root of each element. So all of these are kind of element-wise operations. So whatever we say, it performs it to each element separately. Now we're going to look at some functions that have to do more with decimals. So I'm going to create a new array and call it ARR-DEC. And we're going to call this rand_n function, pass in a 10. And this is going to output a random array that goes from -1 to 1 that has 10 elements. So these are all between -1 and 1, and it's easier to explore things when we have a more varied array. So I'm going to multiply this whole thing by 5, and it's going to kind of get some more variance in here. So now that we have this, I'm going to say np.ceil and then say ARR-DEC. So what this is going to do is it's going to kind of round everything up. And so -1.5 rounded up is -1 because -1 is greater than -1.5. Similarly, the next one, 1.07 rounded up, is going to be 2. So how I remember ceil is basically ceiling is up above, so it rounds it up. Now, kind of contrary to this, it's pretty self-explanatory. np.floor. Floor is on the ground, it's going to round down. So instead of rounding up, when you say np.floor ARR-DEC, it's going to output an array where each element in the original array ARR-DEC is rounded down, as we can see right here. Now we're going to try np.trunc, and so this one is going to truncate each decimal. So it's basically going to discard everything that's after the decimal in each element. And so -1.59 blah blah blah, it's going to take out that 0.59 and just output -1. Now the last one we're going to look at is absolute, which takes the absolute value of each element. So it just takes off the negative sign for each one. So this is kind of a sample of the operations that are available in the NumPy library. If you'd like a more complete list, you can go ahead and click on the link that I've included in the description box. If you're not familiar with Pandas, then I've created a video where I explain the basics of this Python library. So you're welcome to check out that before you watch this video. In this video, we'll be learning how to turn a Python list, NumPy array, and a dictionary into a Pandas series. We'll also be learning how to perform indexing and selection on Pandas series, creating a data frame from scratch, performing indexing and selection on a Pandas data frame, and lastly, relating Booleans and data frames. Let's jump right in. So we're going to go ahead and start by importing NumPy as NP, as we've been doing for the past few videos. And this time we're going to have a new import, which is Pandas. So we're going to import Pandas as PD. Okay, so in this video, we're kind of going to explore how we can turn Python lists, NumPy arrays, and dictionaries into Pandas series. And we're also going to explore some data frames with Pandas. So we're going to create a variable called Python list. And we're just going to set this equal to 1, 2, 3, which is a simple Python list. Next, we're going to create a NumPy array. So we're going to label this array and then say np.array. And we're going to turn this Python list into a NumPy array. Then we're going to create a dictionary. And if you're familiar with Python, you'll kind of know the syntax. But basically, we have a key and then kind of a value that goes with that key. So in this case, our keys are going to be x, y, z, which are just letters. And then our values are going to be the same as our list. So 1, 2, and 3. So we're going to match 1 to x, 2 to y, and 3 to z. And then the last thing we're going to do is create another Python list called letters, and you'll kind of see why I'm creating this now a little bit later. So these letters are just going to be the same x, y, and z. So once you've created this, we're going to create our first Pandas series. So to do this, the syntax is pd.series with a capital S, that's pretty important, and then parentheses and Python list. So this is turning our Python list, 1, 2, and 3, into a Pandas series. So as you can see, it's kind of in 2 columns. So the first column indicates the index, so 0, 1, and 2. And then the next column indicates the actual values that correspond to each index. So 1 corresponds with 0 index, and so on. Now we're going to convert the NumPy array into a Pandas series. And it actually outputs the same thing because our NumPy array is basically our list turned into array. Okay, so now we're going to try customizing the labels. So when I say labels, I basically mean the indices. So when we say Python list, comma, letters, we're basically indicating that we want the data to be Python list, and then the labels or the indices as letters, which is x, y, and z. That's a list. And we can also replace Python list with the array, and we'll get the exact same output. So next we're going to convert our dictionary into a Pandas series and see what it outputs. So in this case, since we kind of have 2 different lists but merged together, it's going to output the same thing as we had last time. So x, y, z, 1, 2, 3, where each key is each label. And then the value that corresponds with the key is going to be our data. So 1, 2, 3. So same output for these past 3 lines of code. So now we're gonna create a variable named ser, short for series, and we're going to set that equal to our dictionary. That's now a Pandas series. And this is kind of selection based on a series. So if we do square bracket 0, we're just going to get the value that corresponds with the 0th index, which is 1. And we can also replace that with an x since it's labeled in this case. So basically the 0 is the same as the x because it's just talking about the 0th index. So now we're going to learn a little bit about data frames. So we can think of a data frame as basically a bunch of series objects put together. And what's important to notice is that they all share the same index, which we'll see in just a moment. So we're going to create a data frame from scratch and then perform some operations and selections using it. So the first thing what we're going to do is create a random matrix using NumPy. So we're going to call this rand and then say np.random.rand and 3, 2. So it's going to create a random array of 3 rows, 2 columns, and instead of being restricted to -1 to 1, we're multiplying it times 5 to get a little bit of variance in there. Now I'm going to create 2 new lists, and you'll kind of see why I'm creating these in just a moment. But ind is short for indices, and then col is short for columns. So our indices list is going to be 1, 2, 3, and then our column list is going to be A, B, C. Or sorry, just A, B. Okay, so now we're going to create a data frame. So this is the syntax for data frame. We have a variable, set equal to pd dot data frame, where D is capital and F is capital. And in our parameters, we can do shift tab to see what this will need. So it looks like it needs data, and then it needs an index. So for our data, we're going to say rand, which is actually our two-dimensional array. And this is in a matrix form, which Pandas is creating into a data frame. It has this nice little layout with some variances to black and white, and it has labeled our rows and it's labeled our columns. So now if we want to specify what we want the rows and columns to be labeled, we say ind, comma, col, where ind indicates the 1, 2, 3, where it labels the rows, and then AB is the column names as our third parameter. So now we can perform some selection and indexing using our data frame. So the first thing we're going to do is selecting columns. And this is pretty simple syntax. It's just df square bracket and then whatever column we want. And it outputs that column for us. So it outputs just that column with all the rows associated with that. If we want multiple columns, then we basically just include a square bracket and another square bracket inside of it and say the columns with a comma in between them. So this is just a quick way to get multiple columns. Say we have like 5 columns and we just want to get 2 of them, we can do it through this syntax right here. So next we're going to look at selecting rows. So selecting rows is a little bit more involved, but it's pretty simple. So we just use LOC and then do that same square bracket thing to get the actual row we want. And in this, we have 2 columns, so it's just going to output 2 things. Whatever's in 1 for A, and then whatever's in 1 for B. Okay, so the next thing we're going to do is see how we can use the index to obtain a value. So LOC without an I in front of it just needs the actual index name, which is 1 in this case. But if we want the actual index, which is 0, that corresponds with index name 1, then we input an I before the LOC. Okay, so now we're going to look at how we can get a specific element, because so far we've been doing rows and columns, but if we have a comma in between, then we'll get a specific element. So it's row, comma, column. And so 1a gives us negative 3.8. Okay, so now we're going to look at how we can get specific rows and columns. So this is going to be using the same syntax as what we've been doing, where we say df.loc square bracket. Then we need to have something, comma, something. So row, comma, column. So we need to specify all the rows that we want. So pretend we want rows 2 and 3. We just have another square bracket and indicate that. And then outside this square bracket, we have a comma and then indicate the column that we want, which is A. So it's going to output rows 2 and 3, column A, which is pretty specific. So now we're going to look at how we can add a column. So we basically say df square bracket and then put the name of the column inside and equal that to whatever we want the column to be. So in this case, I'm just doing another random array of length 3, and it has to be length 3 because there are 3 rows in this. So it needs to follow that. But yeah, and then we can drop it. We drop another column by doing df.drop and then an open parentheses, and we can put some labels in there. And what's also important is this axis right here. So this axis is talking about, are we going to drop something in the rows, or are we going to drop something in the columns? If we're going to drop something in the rows, if we're going to drop a row, then axis needs to be set equal to 0. If we're going to drop a column, then axis needs to be set equal to 1 in order to tell the machine that we want to drop a column. So that's why we've done this, and now it's dropped column A. So our next thing is conditional selection. So this is basically saying find out which values in df is greater than 1 and replace that with the true. find out which ones are not greater than 1, and those will become false. So whenever we have a conditional right here, it's going to output a data frame that's filled with Boolean values. So now we're going to look at how we can kind of turn this back into our actual data frame with actual values, and how to kind of replace the false with just undefined, basically. That's what the NaN means. So we did that by putting df equal or greater than 1, that conditional statement, in the square bracket. Now next, what I did was I kind of said specifically for the B column, what's greater than 2? And that outputted a series, because it's just a column, right? It's not comparing it to the whole data frame. A series with true and false depending on whether the value in B originally was greater than 2 or not. And then this is converting it back into a data frame. But what it's actually doing here is it's taking out both of the falses. So rows 2 and 3, it actually had false for is a value in B greater than 2. And because it had false, it had to take those two rows out. So it's left with just a 1. Okay, so what we're going to do now is kind of see how we can use logical operators with conditional statements and data frames. So for logical operators, those are and or. We basically need df square bracket, and inside the square bracket we're going to have open parentheses, and then either an and or an or separating the two statements. In the first one, I'm just going to insert what we already have. So we're going to check for column B, whatever's greater than 2. Then in the next one, I'm going to check C is greater than, let's say, 0.7. And in this case, we can actually see how, so the first statement kind of filters it down to line 1, as we saw before. And the second line, there are actually no values that are greater than 0.7 or 0.5. And so it doesn't output anything. Well, it's a blank data frame because nothing is able to fit both those conditions. If we change this to 0, it doesn't work either, right? So we want to find something in 1, just row 1, because we know that the first condition already filters it down. And so we can try -2, and yeah, that outputs something because we have a value in C in 1 that's greater than -2. Okay, so that was pretty much it. So as just a quick review of what we've done here, we imported pandas, which is new. Then we started creating Python lists, Numpy arrays, and dictionaries into pandas series. That was what we did in the beginning. Then we went on to kind of selecting, doing some indexing and selection on the series. Then we looked at data frames. We saw how we could perform some selection on that as well. And then finally we got to conditionals, and we reviewed how we can kind of relate the Booleans to data frames, how we can kind of go back and forth. In this video, we're going to be exploring Pandas grouping mechanisms. We'll learn about concatenating data frames, merging data frames, joining data frames, and the Groupby method, which includes attributes such as count, describe, mean, min, max, standard deviation, etc. Let's jump right in. Okay, so the first thing that we're going to do, as always, is import pandas as PD and numpy as NP. Next, what we're going to do to explore some grouping mechanisms, our first one is actually going to be concatenation. So the first thing we're going to do is create 3 data frames. And you'll see that the only thing that's differentiating the data frames is the name of the rows and the values inside. So the column names are going to stay the same. And that's how we know that we can use concatenation. So the very first thing that we're going to do is we're going to create a data set. And this one is just going to be a random NumPy matrix of 3 rows and 2 columns. And remember how rand n actually only goes from -1 to 1. So we're going to multiply it by 5 to get some variance in there. The next thing is we're going to create a column Python list. So the names of the columns will be A and B. And then the next thing is the names of the rows. And so this is going to be 0, 1, and 2. And we're going to turn this NumPy matrix into a Pandas data frame. So like if you remember, if you do Shift Tab, you can kind of see what it includes. And so it needs data, index, and columns, which are going to be data 1, and then ind1 and col1 are the parameters that we're going to insert in here to create our data frame. And now we can look at how it looks. So as you can see, we have some values that range from vary a lot because we multiplied it by 5, and then we see A and B as the column names, and then 0, 1, and 2 as our row name. So the next thing we're going to do is create another data frame, and this we're going to just copy this first one and change a couple of things. So as I said in the beginning, we are going to keep the column names the same, but we're going to change the other things. So the first thing is to change everything to a 2 from a 1. We're going to keep the first row of this cell the same because random arrays will make it different every time. This one we're going to change to 3, 4, and 5 instead of 0, 1, and 2. And then again we're going to change these to 2 so that it can match up. Now we're going to look at this and we see that the column names are the same, the values are different, and the row names are different, which is what we wanted. Now for our last one, we're going to do the same thing, change everything from a 2 to a 3. We're going to keep the first row the same because it'll be different anyway. We're going to keep the column names the same, but we're going to change the row names to 6, 7, and 8 this time. Okay, and now we're going to see how it looks. And it looks like that, just like expected. So now we have 3 different data frames with different row names, same column names, and different values inside. So now we're going to see how we can concatenate these. And so when we concatenate by row, they'll basically put the data frames one on top of each other. So the syntax for this is pd.concat, which is pretty self-explanatory. And inside, we're going to have the data frames that we want to concatenate. So in this case, and yeah, we can do Shift Tab to kind of see how we need to insert this. This is a little confusing, but basically what we need are data frames, which we have. We have 3. So we're going to write df1, df2, and df3 as our 3 data frames. And that's the only parameter we're going to insert for row-based concatenation. So it's taking all of these rows, putting them just one on top of each other in order, and basically everything else stays the same. So no values are deleted or replaced or anything like that. Other thing we can try is column-based concatenation, which we'll have to specify the axis equals 1, because remember, axis equals 0 means row-based something, and axis equals 1 is column-based. And so since we want to concatenate by column, we need to say axis equals 1 as our second parameter. So the syntax is going to be pretty much the same as what's in cell 13, but just that addition is there. So when we have column-based concatenation, it just puts them side by side rather than on top of each other. But since we still have indices that are 3, 4, 5, and 6, 7, 8, we're still going to have on top of each other because all of those still need to be accounted for. We can't just stop with 0, 1, and 2. But as you can see, in the places where, in the data frames where we don't have a particular index set, such as the first one doesn't have 3, 4, 5, 6, 7, 8, and so all of those are missing values, or NaNs, because they don't exist. So it's just kind of a diagonal that has everything, and everything else is just non-existent. But this is how to do column-wise concatenation. Now the next thing we're going to do is we're going to see how to merge data frames. So the difference between concatenation and merging is that when we have merging, it kind of uses one column that's the same between the two, and it's able to merge it on that column. And so we don't have, when we put them together, we don't have repeating columns, because the one that's the same is just merged one on top of one another. And so that's also how we can tell that we want to use merging, is if we have a column that's exactly the same between two different data sets. So the first thing we're going to do is we're going to create a data frame. This one we're going to call df1 equals pd.dataframe. And in this one, instead of using these Python lists to, as parameters, we're just going to use a dictionary. Because if you can remember from a previous lesson, we can just use a dictionary to specify everything that we need to in just this line. And so what it does is it takes the key as the column name, and then the list that we refer to that key as the values in the data frame. And it actually defaults the indices to just 0 through whatever. So our first column is going to be called combine, which, if you can guess, is the one that we're going to be combining on. And so this column is going to be common between df1 and the second data frame that we're going to create. So in this one, the values inside of the combine column are just going to be CO1, CO2, and CO3, CO4. And that just is short for column 1, column 2. But you can kind of create any variables you want to. But just make sure to include some letters so that it doesn't add up any values. If you just include numbers, it might add some values up. So we want to have strings as the values to really see that it's working. The next one, the next column that we're going to have is going to be called A. And what it's going to have is A1, A2, A3, and A4. And then finally, we're going to have column B, and that's going to have B1, B2, B3, and B4. So now we're going to view this array, this data frame, so df1, and this is how it looks. So it has a combined column, and then the A and the B, and the indices are just the default, so starting from 1 up till 3, starting from 0 up till 3. Now we're going to create a second data frame that we're going to merge with this one. So we're just going to copy and paste this and change all the 1s to a 2. And the other thing that's going to change is column A and column B, and those are going to change to column C and column D with the corresponding C1, C2, C3, C4, D1, D2, D3, and D4. And the combined column is going to stay the same because we want one similarity so that it can have something to merge on. So we're going to view this, and this is how it looks. As we expected, the combined one is the same, but we have C and D with corresponding different values. So now we can explore kind of how we merge. So this is pd.merge, which is pretty self-explanatory. And we're going to specify two different kind of data frames that we want to merge, and then what we want to merge it on. So we want to merge it on combine in this case, just because that's the similarity between the two. So as we can see, once we merge it, all of the columns are accounted for, but we don't have a double combine one, which is the speciality of merging. It doesn't repeat anything. So the next thing we're going to do is we're going to see how we can use joining to join data frames that don't have the same index. So far we've seen how these ones have the same index when we combine. When we merge. But this time we're going to see what happens, or what we do if it doesn't have, the rows don't have the same names. That's where joining comes in. So for this, we're going to create two different data frames again. And this time it's going to be where we have all the columns are going to be different. But one of them, so basically we have A, B in one data frame, and then C and D in another one. And they're going to follow the same format. But in this case, we're going to actually specify the index. So last time we just let it be default. This time we're going to set it differently for each one. Just slightly differently, but they will be different, as you can see. Okay, so as we can see here, we have two data frames that we want to join. And we use this kind of syntax to join data frame 2 to 1. So that basically means that we're going to keep data frame 1 as is, but we're just going to join data frame 2 for any row names that match up. So as we can see, we have 0, 1, and 2 as is. But since data frame 2 has the first I1 and I2 that's common between the two, it adds the values for data frame 2 to those, and then since it doesn't have it for 0, it just has that as missing values. And so if we want to switch this around to say data frame 2 dot join data frame 1, it's going to keep data frame 2 as is, and it's going to just join whatever matches up with data frame 2 in data frame 1. And so in this case, we see kind of 1, 2, and 3 as is, but since 1 and 2 are common between the two, it's able to match that, and I3 is not in data frame 1, and so it's not able to match that. Okay, so now we're going to look at our last kind of area of Panda grouping methods, which is group by. So for group by, basically it'll be easier to kind of visualize what this does if we have a data frame that we can work with and use group by on. So let's first create that. So we're going to create a data frame that kind of plays out the scenario of someone in an ice cream shop. And so we're going to call that df, just data frame, since it's only going to require one, pd.dataframe, and then inside here we're going to use the same dictionary method. And so we're going to have number of scoops as one column, and this one we're going to have the options as 1, and then another 1, then 2, another 2, 3, and another 3. So we have kind of some repeat values, which is exactly where group by comes into play. When one of the columns has kind of repeat strings or repeat numbers, that's where you can kind of tell yourself that group by is something that you can use for this. And you'll see why in a second. The next column name is going to be flavor. And for this, we're going to do all different. Same with the last column, that's going to be price. So we're going to say vanilla, chocolate, strawberry, cookie dough, peanut butter, and pistachio for flavor. And then price is going to be $1, $1.50, $2, $2.50, $3, and $3.50. So it's just incrementing, and they're all different from each other, which is the goal. So we only want one column that kind of has repeat values. Okay, so now we're going to see how this data frame looks. And to that, we're just going to say df. So we can see that there's number of scoops, flavor, and price as the columns. The indices we didn't specify, so they're just the default. And then number of scoops, we obviously see there's a couple 1s, couple 2s, and couple 3s. So now what we're going to do is create a group by object. So this is going to be group equals df.groupby, and then we're going to group by the number of scoops, because this is the one that kind of has repeating ones. And so this is actually not going to output anything if we say group, because it is an object, and so it's not actually like a data frame in itself. It's just an object that's storing a form of this data frame, which is a group by. And so what we're going to do with this is we're going to call some methods off of it, because that is the purpose of group by. It's to kind of analyze our data frame in terms of one column that's repeating. So we can do group.count to see the counts for each number of scoops. So for one number of scoops, we have 2 flavors and 2 prices, which we know because there's the vanilla and chocolate, and then $1 and $1.50. Same with the next 2. We can also do group.describe, and this is obviously going to describe different aspects of the 3 numbers of potential scoops that an ice cream can have. And so we see like count, median, mean, things like that. And so it does that based off of the data frame that we have. So for example, mean is just going to average 1 and 1.5 to get 1.25. And we can also describe based on just one of the types of number of scoops. So if you remember how to get one of those rows, it's going to be .loc. Because columns we can just specify with the square brackets, but rows we need that LOC. Okay, so next we're going to take a look at how to find the mean, and we can see this from our data frame of kind of aspects of the data frame above, but we can also do it by just saying grp.mean, which is an easier way to get it. Next we're going to look at a couple more things. Oh, and also a quick note about this mean one, it only works on numerical data, which is why it didn't work on the flavors. Yeah, so we can do it on min, we can find the minimum value. So out of the 2 possibilities for 1, between 1 and 1.5, 1 was the minimum. So it gives that, and then the flavor that corresponds with that minimum price. Then we can find the max, which does the other one, and then we can also do the standard deviation, and that is also in this chart, but this is how to get it by itself. So these are just some of the methods that we can call off of Groupby. There's obviously a lot more, and you can explore that if you'd like. So just a quick recap of what we've done today. So we imported the libraries, and then we created 3 different data frames using Python lists and Numpy arrays. And we first saw how to concatenate it row-wise, so it puts it one on top of each other, and then column-wise it puts it side by side. And then we created 2 more data frames that we use to see how merging works, which is basically where if we have a column that matches exactly, it's able to merge it on that column and create a new data frame. And then we created a couple more data frames that we use to join. And so this one basically is if the index names are differing between the data frames. And finally, we did some group by exploration. We created a data frame where one column had repeating values, and then we called some methods off of it, which we just went through. In this video, we're going to be exploring Pandas operations. We'll learn about how to get column and row names, how to apply functions to columns. We'll learn about methods such as unique, and unique, sort values, sum, value count, and we'll work with missing and null values. Let's jump right in. Okay, so the first thing we're going to do, as always, is import 2 Python libraries, so Pandas and Numpy. So we're going to say import Pandas as PD and import Numpy as NP. Next, we're going to create a data frame that we can work with to explore some of the Pandas operations. So this data frame is going to be called df, and then as always, we're going to say pd.dataframe, and then just parentheses, and then we're going to have a dictionary inside to indicate the column names and the values inside the data frame. So our column names are just going to be C1, C2, and C3. And our values, we're going to have 34, 45, and 34. And so the main thing in C1 is to have some repeating, because we want to, that's one of the things we'll explore later on. Then in C2, you're going to include some strings. So I just did A, B, and C. You can do whatever you'd like. And then C3 should just be some numbers. So I just did 1, 2, and 3. So we're going to run this and see how it looks. And as expected, we have column names, C1, C2, C3, then indices, the default ones, and then all of our values inside. So the first thing we're going to see is how to get column and row names. So column names is pretty much df.columns, and it's going to give you a list of the column names. So C1, C2, C3. Now for rows, we just say df.index, and this will give you, it won't give you the names, but it'll give you the information about the indexes. So we have a start, 0, stop, 3, and step 1, so that's pretty easy to figure out that it's going to be 0, 1, 2, and then as always, we don't include the last number, so it stops at 2. So now we're going to look at how we can get the sum of values in a column. So if we want to get the sum of the values in column C3, then we just say df square bracket C3 dot sum, and it adds up 1 plus 2 plus 3 to get 6. Now we're going to look at how to apply functions to columns in a data frame. So as always, how you start a Python function is def, and then you have a name of the function that's explaining what it does. So this one is going to take x, whatever x is, to the power of 3. And so it's going to return x and then asterisk asterisk 3, which is x to the 3rd power. So now we're going to apply it to the column C3. And so this is just going to be df square bracket C3 dot apply, and then this function. And so it's going to apply this power 3 function to every value in the C3 column. So every value is going to act as x at a certain point. And it's going to power each one to the 3rd power. So as you can see, 1, 8, 27 is correct. So now we're going to look at how to get some info on how many times a value shows up. So this one's going to be D1, square brackets, C1, and then value counts. And value counts is just going to give how many times each value in C1 is going to show up. And so since we have a repeating of 34, it shows it as 2, and then 41 is just going to be 1 because that only appears once. Now, if we want to get a list of the unique values in C1, we just say df c1.unique, and that's going to give a list of the unique values, and we know that's going to be 34 and 45. And if we want to get kind of how many unique values there are, we just copy that and we just add an n for number of unique, and we get 2. So that's how many unique values there are in that particular column. Now we're going to look at how we can sort values by a particular column. And we're going to do C1. So this basically just orders it in terms of C1. So 34 is less than 45. That's why those two are first. And it doesn't account for any of the other columns. It just looks at this one and it orders everything based off of this one column that we've given it. Now we're going to see how we can work with missing or NaN kind of non-existent values. So what we're going to do here is we're going to copy and paste this data frame and just add in some non-existent or undefined values. So we're going to make this, instead of a 3x3, we're going to make it a 3x4. So we're going to have it's going to be a 4x3. So 3 columns still, but 4 rows. And we're just going to add an np.nan, which is NumPy's version of a non-existent value. Yeah, so as we can see here, we have a data frame and basically the same thing, but now we have a couple NaNs existing. So we can say df.isNull to check which of the values are null. So this is going to output a data frame with a bunch of Boolean values, so true and falses. And it's going to have false for whichever ones are not null, and then true for whichever ones are, so we can see which ones are null. We can also see that by looking at it, but if we have a more complex data frame, then this is helpful. And we can now filter it based off of this, so we can say drop NA, which is going to drop all of the non-existent values, or null values. And then we can also say fill, and we can fill with a particular value, or we can fill it with a string. So the syntax for this is just going to be df.fill NA, and then in parentheses as a parameter, we can just have whatever we want to fill it up with. So in this case, I just said hi. So it's going to fill in both of those NaNs with hi. Okay, so now we're going to do a quick recap on what we did in this video. So we imported the libraries, then we created a data frame through which we got the columns and the index, and then we also saw how we can do a sum, and then apply a function to specific columns, and then get the value counts and also a list of unique values and the number of unique values. And then we saw how we can sort values by a column. Next, we created another data frame in which there were some missing values, and then we learned how we could work with that and drop it and fill it and things like that. In this video, we're going to be exploring how to create plots using Matplotlib, which is another Python library. In my very first intro video to this Python for Machine Learning series, I introduced Matplotlib and basic features of that. So if you aren't familiar about what Matplotlib is, I'd suggest you check out that video. So in this video, we're going to be exploring how to create X and Y arrays, how to use basic Matplotlib commands, how to set X and Y labels and titles. We'll also learn about the object-oriented method of creating plots, and then how to learn or how to create subplots and how to work with them. Let's jump right in. Okay, so the first thing that we want to do is import NumPy as NP. And we also want to import Matplotlib this time. This one is not just going to be import Matplotlib. We're going to have a little extra. So it's going to be matplotlib.pyplot as PLT. And then after this, we want one more line of code to ensure that we can see the plots in the Jupyter notebook. For other notebooks, you can use plt.show at the end of the commands to have the figure show in another window. But if you're using Jupyter, then you want to have a %, matplotlib inline. And this is going to, as I said, ensure that you see the plots underneath your commands. So as always, as with any graph, we want X and Y axes. So for this, we're going to define X as np.arrange with a 10 inside. And this is basically just going to be a NumPy array of 0 through 9. And then for Y, we're just going to multiply X times 2. So this is just going to be every element times 2. So now that we have an X and a Y, we're going to use some basic Matplotlib commands to show this plot. So this is just going to be plt.plot, and we want to plot the y versus x as it says in the doc string. So to do this, we're just going to say x comma y, and this is going to plot, it's going to output a graph where we have a line that connects these x and y's, as you can see, and the scales are all correct and the values are correct as well. So what we want to do next is we want to see how to get rid of this top portion. And so to do that, it's just a very simple line right after, which is going to be plt.show. So what we're going to do here is we're going to retype plt.plot and then x and a y. But under that, we're going to have another command that says plt.show, which will basically, it's kind of like print versus like not printing. If we have print and then we have a string versus if we just have the string, same type of scenario. So we have that. Next, we're going to see how we can set x and y labels, as well as a title. So we're going to, again, say this plt.plot and an x and a y. And then underneath, we're going to say plt.xLabel. And then in parentheses, we need a string that indicates what string we want in the x label, which is the x-axis. And we could do the same thing for y. So basically just copy and paste, and then replace the x's with a y. Then we can set the title by saying plt.title, and then we can just have whatever string we want for the title. And finally, plt.show, so that it can output a nice graph. So we see the same graph, but with an x-axis label, y-axis label, and a title. So now what we want to do is use an object-oriented method to create plots, which is basically, instead of saying plt dot, which is the generic command, we want to have a specific object of this plt so that we're able to kind of customize it even more and add some extra layers to it. So what we're going to do to create this object-oriented is we're going to have a variable called plot in which we're going to store plt.figure. And what this is going to do is it's going to allow us, it's basically our model of the graph, and we have to set some axes based off of this object that it's created now, which we can say by doing axplot equals plot.add axes, and then the inside the parameter we have this list of numbers where the first number indicates the left, the second number indicates the width, the bottom, third number indicates the width, and the fourth number indicates the height. But this will make much more sense in a moment when we put a plot inside of a plot, and we'll see kind of what this canvas is talking about. But just remember that what's in the parentheses has to be between 0 and 1. But as I said, it'll become much more clear in just a second. So now what we're going to do is, and then just make sure that's an equal sign. And now what we're going to do is set some x and y labels. Or first plot it using x and y, and then we're going to set some labels. So the only difference here is that instead of just saying .x label, it's going to be .set x label. That's the differentiating factor between the two. And we're going to set that as x-axis, and then do a similar thing for the y-axis, and then we're also going to set the title by saying set title, and that'll be the only difference between the two. Okay, so now we can output this and see how it looks, and it looks pretty good. So we have the x-axis, the y-axis, the title, and our graph. And it's a little bigger than our last one because of this dimension of the axes, which is why it's helpful to use object-oriented, because we can really make it more specific to what we want. So for example, if we decrease the last one, which is the height, by half, then it's going to kind of like smush it together because it's cutting the height by half. Similarly, if we do the third one, which is indicating the width, it's going to cut the width by half. So it's becoming smaller, as you can see. So basically, the parameters indicate how big our canvas size is going to be. So the next thing we're going to do is create a plot inside of this plot to see how that works. So we're just going to copy and paste this whole thing, and wherever it says axplot, we're going to change that to axplot2 because we need to have the variables be different. And then here we're going to have x-axis 2, y-axis 2, and then title 2. And the final thing we're going to do is we're going to change the size to make it smaller and inside. So 0.2, 0.2, 0.5, and 0.5, and you'll see in a minute what this means. So as you can see, it kind of moves inside, and how we got it inside was because the first one we changed to 0.2, which means that it's going to move 0.2 to the right, and then the bottom is going to move 0.2 up, and then 0.5 is it's going to be half the width of the original and half the height of the original. And so we can kind of like play around with this a little bit. So if we kind of change this to 0, it's going to smush it to the left because it's not going to move to the right any amount. If we have this as 0, it's going to be all the way towards the bottom. And then similarly, we can play with this. So this one's going to make it really wide because it's not going to cut the width in half. And this one, if we make this also one, it's just going to totally overlap, which is why it's throwing a little bit of a warning because we're just basically using the same graph but overlapping. Which serves no purpose. So that's just a little warning, but this is how or what the parameters for the axes size means. And finally, we're going to learn how to create subplots. So subplots are helpful if we want to create many plots on the same canvas so that we don't have to repeatedly create more and more canvases. So here we're going to use tuple unpacking to do this. So that's going to be fig, which is figure, and then comma axes. You can specify whatever variables you want for those two though. And then plt.subplots, n rows equals 2, and cols equals 2. You can say whatever you want for the number, but n rows stands for number of rows, and cols stands for number of cols. And since we set both equal to 2, that's why we have 2 rows and 2 columns. So if we replace this with a 5, then it's going to output 5 rows and 2 columns, which is a little smushed in this case because we just have such kind of a lot of rows, but we can kind of customize this a little bit, which we'll look at in the next video actually. And so the next video will also learn how to change the colors of the plot and how to make it smaller, bigger, how to add markers and things like that. But for now, let's do a quick recap of this video. So in this one, we imported these new libraries, and then we have an X and a Y, and then we just plotted it. Then we set some X and Y axes, and we used the object-oriented method to create plots. And then we saw how we could edit the axes, and then how we could make the graph bigger and smaller. We ended with creating subplots. In this video, we're going to be exploring customizing plots using Matplotlib. We'll learn how to set labels and titles, create legends, move legends around the canvas, and customize colors, line widths, line types, transparency. We'll also learn how to customize marker, marker size, marker face color, etc. Let's jump right in. Okay, so we're going to import Matplotlib as PLT again, just like the last video. And we want to insert that little line to make sure that we can see all the charts. Then we want to import NumPy, because we're going to use that to create our X. So for our X, we want to say np.arrange, and then with a 10. So that's just going to be the NumPy array from 0 to 9. And then our Y is just going to be that times 2. So element-wise multiplication. And this is the same thing that we did in the last video. So I'm going to kind of go through this next part pretty quickly because we went in depth in the previous video. So if you don't really know what's happening right now, I'd suggest you check that out as well. And so basically here we're just creating object-oriented method of creating a plot. So we're creating an axis, and then we're setting an X and Y label as well as the title, and then we're just showing the graph, and it looks pretty much the same as what we expected. And now we can kind of see how that looks. So the next thing that we're going to do is we're going to add a legend to this. So how we're going to do this is basically we're just going to copy and paste what we have above, except we're going to add a couple of things. So the first thing that we're going to add is axplot.legend. So this indicates that we want to show a legend. Now we're going to copy and paste this plot line so that we can add another line that's a little bit different. So it's going to be x times 3, comma y. And we're going to label this as x times 3, and then the top one is just going to be x. So when we output this, it's going to have a legend at the top, and it's going to indicate that our orange line is the one that's x times 3, and the blue line is just normal x. And so what we can do with this is we can kind of move the legend around, and there are different options so that if the line is in a particular spot, the legend doesn't overlap with the line and things like that. So it really helps us kind of customize it a little bit more. So if we say LOC equals 1, then that's going to put it at the top right corner. LOC equals 2 is going to put it at the top left corner, and then LOC equals 3 puts it at the lower left corner, and LOC equals 4 puts it at the lower right corner. And so the easiest thing, or the most common thing, is to say LOC equals 0, because this one lets Matplotlib decide the optimal location for the legend. So it makes sure that it won't overlap with any lines, that it doesn't clash with the scaling, with anything like that. So it's saying that the optimal location is the top left-hand corner in this case. Okay, so now we're going to look at how we can kind of customize the plots even more by adding some colors and some markers and line widths and line types and things like that. So the first thing that we're going to do is just create another figure, and then we're going to add some axes to this figure, which is just our normal 0, 0, 1, 1. And then we're going to start plotting. So in this case, we're just going to do x comma x instead of x comma y, and our color is just going to be blue. So this is how we indicate the color, and it's just going to change the color from what it normally is to blue. Now we're going to copy and paste this line to see another type of line. And this time I'm just going to multiply this times 1.5 so that it can be differentiated from the top one and it doesn't overlap. So we're going to copy this over and then change this color to a custom color. So we're going to use hex coding, and so we're going to say D31ED4, and this is just going to give a magenta color, and make sure to put the hash in front of it. So as you can see, I did x times 1.5, so it is overlapping. But you can make sure that it doesn't overlap by saying like x times 2, and then the next one can be x times 2.5 or something like that. And then this alpha one actually makes it transparent, but you can't see that right now because it does overlap. So I'm just going to change this real quick so that the lines don't overlap and we can really see the difference between the different lines that we have here. Yeah, so as I said, alpha makes it transparent, so we see the same magenta color but a little bit more transparent. Now the next thing that we're going to do is copy this line, and then we're going to change the line width to 1. And so, and we're also going to change this color back to blue. So what this line width is going to do is, as you can maybe imagine, it's going to decrease the line width to just 1. So it's going to appear a little bit more thin than usual. Yeah, so we can see that at the very top, it's a little more thin. And so if we want to make that thicker, then we can do that as well, which is what we're going to do in the next one. And also what we can see in the next one is that we don't actually have to write out line width. We can just say LW, and that indicates that it's going to be line width. And yeah, make sure to change it to 3.5 or a bigger value so that you can really see the difference. So yeah, as you can see, it's a little bit thicker. The next thing we're going to do is change the line style. So if you can notice in all of these lines, it's just a straight line. But what if we didn't want to change the color, but we still wanted some other way to differentiate? We can change the line style. And we can make it these different types of designs. So this one is just going to look like a dash and a dot, which is what we can see here. And we can also shorten this to LS, just like how we could shorten line width to LW, we can shorten this to LS, and that's what we're going to see in this case. So we're going to, we'll do a colon in this case to see how that outputs, and this one will basically be just a bunch of dots. Okay, so the next thing we're going to do is kind of play with markers. So what markers do is it puts a kind of dot or whatever marker you choose in each of the locations that is really concrete. So if we have x equals 1 and y equals 5, for instance, then it will put a marker there. It won't do it in locations that are more decimal related, but it'll put in these concrete locations with solid numbers. So as you can see, the first time I did a plus sign, second time I did a circle using an O, and then now I did an S, and I'm also doing marker size, which is going to just increase or decrease the size accordingly. So if we put this as 10, it's going to be super big. And then the last thing we're going to explore is marker face color. And this one is basically just going to change the color of the marker itself. And I put green, so it's changing the inside to green, but keeping the outside borders blue. So that's pretty much it. And just as a quick recap, we kind of reviewed the same things that we did in the last video, and then we saw how we can move around a legend and create one, and then we used some customization to enhance our graph, and we viewed marker color, marker size, marker face color, and then color of line, and then different line widths and line styles and things like that. In this video, we're going to be exploring Seaborn regression plots. Seaborn is another really useful Python library for visual representations. If you'd like to know more about the fundamentals of Seaborn, you can watch my first Python for Machine Learning introduction video. We'll learn about exploring inbuilt datasets, part of Seaborn, working with one dataset, creating a linear model plot, utilizing hue and markers for specificity and customization. Let's jump right in. Okay, so first step is to import some Python libraries. So we're going to import Seaborn as SNS. And then we want to have this line again, the Matplotlib inline, because this also requires us to show the plots in Jupyter Notebook. Now the next step is to import or to load a dataset. And Seaborn actually has some inbuilt datasets, so we're going to use this tips one. If you'd like to explore some other ones, you can kind of search that up on your own, but this is the one we'll be using in this video. So it kind of shows a restaurant scenario where there are different kind of features, such as total bill, time, size, things like that, and we can predict the tip of an order based on that. So based on all these features, what is the predicted tip of a customer to the restaurant? So the first thing that we're going to do is explore a linear model plot. And so this is lmplot. And how we're going to do this is we're going to say sns.lmplot. And then we're going to see, we are going to see by doing shift tab what it needs. So it needs an X, Y, data, hue, call, row, palette. These are all options, but the main things that we need are the X and the Y and the data, which is the first thing that we're going to do here. And then I'll show a couple more variances to customize it even more. So our X in this case is going to be total bill, and our Y is going to be tip, because tip is the thing that we want to predict, and in this case we're predicting it based off of the total bill. And then our data is of tip. So here is just a visual representation of the relationship between total bill and tip. So we can see that it's pretty linear, and the more the total bill is, the more the tip is predicted to be. So the next thing that we're going to do is kind of customize it a little bit more by adding a hue layer. And what this hue does is it basically color codes it based on whatever column we specify. So here we're doing it based on time, so it's going to have two colors, one for lunch and the other for dinner. And this allows us to kind of visualize the effect of the time of day on the tip based on the total bill. So it kind of integrates three variables, even though it's a linear model with only an X and a Y. So the next thing that we want to do is change the markers. So for this just allows us to have both of them not as circles, but different shapes. And so in this case, our lunch is a circle, and we've changed the dinner into a square. So far, we've seen how we can add a hue to differentiate between both on the same plot. But now we'll look at how we can separate plots into two based on a column. So it's still going to kind of use the time to differentiate between the two, but this time, instead of having it on the same one, we're going to have two different plots. So we're going to do this by saying sns.lmplot and then the same x and y and the data, but this time the column is going to be time rather than the hue. And as you can see, there are two plots on the same canvas here, one for time equals lunch and the other for time equals dinner. So same output, just different visualization. Now the last thing we're going to do is change the size, and so this changes the size of the overall canvas. So when we make it 10, we make it much bigger. So the dots appear smaller, and overall it just kind of scatters them out even more. If we change it to 50, it's going to be absolutely huge. We can't even make sense out of this. All we can see is that there is a linear correlation, but we can't really see how far apart the points are from the lines and things like that. So it's not too helpful. So I would say, and this is way too small. So kind of how it was before would be best. So just to recap, we imported this data set, and then we saw a simple linear model, and then we added a hue, and we also created some new charts where we have two of them, and then we played around with the size a little bit. In this video, we're going to be exploring Seaborn categorical plots. We'll learn about creating a count plot, bar plot, strip plot, swarm plot, box plot, and to utilize hue. Let's jump right in. Okay, so for this one, we're going to start out by importing Python library Seaborn, as well as including the Matplotlib inline line in order to show the plots on Jupyter Notebook. The second thing we're going to do is, similar to the last video, we're going to use this tips dataset. So we're just going to load this the same as last time, and also see how it looks by calling tip.head. Yeah, so here we can just see the first 5 rows and these different features, as well as what we're predicting, which is tip. So what we can do here is we can do a count plot, which is basically going to show, well, we can specify an X, which is a column, and it'll basically show the counts for this column. So if we do time, that's going to be lunch vs dinner, and we can see that there are a lot more people coming at dinner, or at least that's what's in this data frame. So that kind of gives us a sense about what we should think about when we see the graphs going forward. And we can also create a bar plot, and this is basically going to take kind of like the average, or the kind of the middle area for the lunch and the dinner. So what is the tip, or sorry, what is the total bill for a person coming in during lunch? Like, what is it usually, the average, and then what is it for dinner as well? Right, so we can see here, usually it's around $17 for lunch, and dinner is obviously more. But also we should remember that more people are there. But that might just confirm that it's probably right, since we have such a large sample size. So it's a little bit over 20 for dinner. So people generally pay more for dinner than they do for lunch, is something that we can kind of infer out of these graphs here. So the next thing that we're going to do is strip plot. So this strip plot will draw a scatter plot where one variable is categorical. And it's called strip plot because it kind of looks like a long strip rather than it being kind of scattered all over the board. It's just kind of vertical dots. So we can do X as the day and then Y as the total bill. So basically we're seeing how the day affects the total bill. And as I said, categorical variables are what we use for these. So day is going to be categorical because there's Thursday, Friday, Saturday, and Sunday. So here's the strip plot. So we can see how generally we see that Saturday and Sunday have a higher total bill, which we also saw through the bar plot. And we can see this because kind of the outliers are higher up. And we'll also look more into this outlier concept when we do box and whisker. But for now, let's try customizing this strip plot just a little bit more to add a hue. So we're going to add a hue as the time. So this one is basically going to have separate colors for each one, and it's going to show kind of how the time is, the time plays a part in this day versus total bill. Yeah, and we can do Shift Tab to kind of see the doc string as well as the parameters. But for now, we will enter this and see. And we see that actually, like, Saturday and Sunday, there are either almost no lunches or just very few. Thursday, there is also, it's actually mostly lunches. And then Friday is mostly dinner, but there are a few lunches, so it's kind of like decreasing. And this might be also why the general total bill is more on Saturday and Sunday. It's because most people come in dinner, and we know that dinner plays a part on the price, the total bill. And so we can also, instead of having it kind of overlapping, we can use the swarm plot to, it's similar to strip plot, but it doesn't clump the data points and separates them out, which gives better approximation of how many values fall in each subcategory. So since it's laid out a little bit nicer and they don't overlap, we can really see that there are like kind of how many there are and where they fall in general. And as I said a little bit ago, we're going to look at box plot, which basically gives a distribution of quantitative data, such as median, IQR, outliers, etc. And so we can look at this to see that Saturday and Sunday, or all of them have outliers, but the ones on Saturday and Sunday are generally more. And then also the general median is higher and the min is actually lower for Saturday, but the max is higher for Saturday and Sunday. And these are all things that we've been seeing through the other plots as well, but it's just a clear way to see it in this box and whisker. And then finally, we can keep this box and whisker idea, but add a hue to it. So smoker, to see if a person is a smoker, do they usually pay more or less? And here we can see that they kind of pay more because generally it goes higher when you have yes, which is blue. So just as a quick recap, we reviewed the tips data set, and then we saw count plot, and we saw this bar plot, and then we moved on to strip plot, where we saw kind of based on categorical variables, and then we separated the split plot, the strip plot, and we saw the swarm plot, where it's a little bit easier to see than a strip plot because it doesn't overlap, and then we finished off with two types of box plots, one with hue. In this video, we're going to be exploring Seaborn distribution plots. We'll learn about dist plot, joint plot, and pair plot. Let's jump right in. So the first thing that we're going to do is import Seaborn as SNS, and we're going to insert the Matplotlib inline line to ensure that we can see the plots in Jupyter Notebook after our commands. Then, just like the previous videos, we're going to have tip equals sns.load dataset, and then we're going to insert this tips. And we're going to see the head, so the first 5 rows of it. And basically, this is a dataset that allows us to predict tip based on a bunch of features, as you can see here. So we're going to create a dist plot, which shows a distribution of one variable set. So that's why we have to specify total bill. And so this kind of shows the frequency, the relative frequency of each one. So we can see that overall it's a little bit less than $20 for most of the total bills. And so we can also kind of customize this a little more by taking out the line of best fit, and we can also add more bins and things like that. So this one, the general layout is the same, except after this we can say KDE equals false, which takes out the line of best fit. And then we can say bins equals 30, and this will just give a lot more bins, and it'll show us a little more specificity in this graph. So we can see, yeah, overall it's around maybe 17, 18, around that range. So now let's look at joint plot. So joint plot allows you to basically match up two dist plots for bivariate data. And you can kind of choose what kind of parameter to compare it with. So here we're going to do x equals total bill versus y equals tip. So we're comparing these two, and our data is tip, and the kind is reg. So that means that the middle graph is going to be a linear regression model. And then the two ones on the side are just going to be these disk plots. And so what this will do is it'll show you kind of 3 plots in the same canvas and allow you to view the frequencies for each one and if they're related linearly or not. So the last one we're going to look at is pair plot, and this one basically allows you to view a bunch of different graphs comparing all of the quantitative variables in your data set. So pair plot will plot pairwise relationships across an entire data frame for the numerical columns, and it also supports a hue argument for categorical columns. And so it's just a simple line, sns.pairplot, and then tip inside, and it's going to output kind of all of the quantitative variables compared with each other. So we can kind of see total bill versus tip, tip versus size, total bill versus size, and etc. And then the ones diagonally going through the middle are the dist plots, and it kind of shows the frequency of each one. So it's a helpful way for us to show a bunch of charts without having to individually do each one. So now just a recap, we viewed a couple distribution plots to view the relative frequency, and then a joint plot to view bivariate data, and this pair plot to view a bunch of graphs for all the data. In this video, we're going to be exploring Seaborn Heatmaps. We'll learn about how to create a correlation matrix, how to create a heat map from the correlation matrix to observe the relationships between variables at hand, and how to customize a heat map, such as colors, line color, and line width. Let's jump right in. Okay, so in this video, we're going to import Seaborn as SNS, and we're going to have Matplotlib inline, just as always, in order to show the plots in Jupyter Notebook. For this one, we're also going to use the tips dataset, like we have been in a couple other videos in the past. So we're going to say tip equals sns.load dataset, and then in parentheses, we're going to mention the name of the dataset, which is tips. Then to view it, you can just say tip.head. And this will give you the first 5 rows of this data frame. So the first thing that we're going to do is we're going to create a matrix form for correlation data. And so this basically relates the quantitative variables. And this is the first step in creating a heat map, because we want to have a matrix that kind of shows what the correlation is between them. So we're going to insert this into the heat map. So we're going to say sns.heatmap and then tip.core, and it's going to output this little chart here. And this is going to tell us what the correlation is between the variables in a colored format. So if we look at kind of like the scale on the side, the ones that are darker have barely any correlation. So we can see like tip versus size is not really correlating with each other. And size versus total bill is a little bit better. But tip versus total bill looks like it's a lot better. And obviously total bill versus total bill is going to be the perfect match, always. So we can also change up the color scheme of this a little bit by doing CMap, which is color map, and changing that to a different one such as cool warm. There are lots of other options, but this is just one of them. And then we can also have this little annotate thing, which allows us to see exactly the values that each color takes on. So for example, the reds are obviously going to be 1 because they correlate exactly because they're the same thing. And then we can see 0.49 is the least, which means that size versus tip is the least correlating. And then we can also, so I'm going to retype this because we're going to change up a couple things. So CMap we're going to turn back into magma. And then we can also change the line color, so basically the line that separates out the rectangles. And then we can increase the size of that line. And so line widths is going to enable us to change up that size. So you can see a little more prominent white border around them. If we change this to 3, it's even bigger. So this is just a little bit of customization for the heat maps. And so just as a recap of this video, we first kind of imported the libraries, and then we loaded the tips dataset. We created a correlation matrix, which allowed us to create these heat maps, and we basically created different types of heat maps. Well, that's it for now. If you've enjoyed the content in this video, make sure to give it a like and comment down below any questions you may have. I've also included a little activity in the description box that relates to the skills we learned in this video, so I welcome you to try that out as well. If you're new here, then make sure to subscribe and turn on notifications so you don't miss any videos that'll help you on your journey towards mastering artificial intelligence. Thanks for watching, and I'll see you in the next one.